Cool. I've just posted this tutorial. I don't know how long it will last. I mean, it's basically up to us to see how far we go. It's not really a tutorial. I'm kind of wanted to go over some work with interested people that we did as part of Ocean Hack Week last year. There was a project set up to try and bring some code over from Python to X-ray for detecting marine heat waves. There's some classic code out there by Eric Oliver, and there's a few papers there. I'll post a link to the repo right now. So this is a link to the repo here.
Hey, Nick, I'm just checking. You want us in the tutorial binder from the last tutorial, is that correct?
Yeah, yeah. And then we'll just install some extra bits in there. When we get going, we'll just install some extra bits to make it all work. I'll just go through it. There's about 3 or 4 lines of typing to add the package we need to that binder, and then off we go. So I'll share my screen now. I'm working with a single screen, so it might get a bit funky. So this package here, it was a really, for me, it was, and I think this is, we've got Ocean Hack Week's going to come up in, when's Ocean Hack Week? It's something like August or so this year. Last year I joined in as a participant, and it was a lot of fun, and I got a lot of help, and it was the first time I'd ever really tried to work with people using all these online tools and stuff. So we set about trying to convert Eric Oliver's marine heatwave code, which is in NumPy, lots of loops, and Python, and try and convert that to an X-ray code. So as you can see down here, there's a description, and we've got some nice bits of the equation there. So the equation basically says how the climatology is going to be prepared, and how the thresholds are taken, and then the definition of a marine heat wave is so many days above that threshold. So it was kind of interesting, because this maths here, it sort of reads okay, but when you look at the code, there's a lot of slight differences with the code, especially with the way it handles days of the year and leap years and things like that. So I'll just fire up this code here, and I'll talk about this code. Now I might have to make this code make this screen a bit bigger for people to look at. So what we set about doing was trying to generate the same code in X-ray as we had in Python, get the same results. Now I'm more of a software engineer. I'm not a marine heatwave expert, but it really fascinated me about how you would take some code written in standard Python and convert it to X-ray and get the same result. So this is the original code, and all I've done here, see there's 2 things in the chat here. Can anyone see? It would be helpful to increase the size. All right. There we go.
Yeah, just checking whether or not people can see well. It probably depends a little bit on whether people are watching on small laptop screens or big monitors. But yeah, maybe that's a helpful thing.
Yeah. So I think Control plus, I think that does make it bigger. I think that might be too big now. So the original code was like one function, and when we go down into it, it creates a climatology, and it has some. So I took that code and I just did a very, very slight modification on it, just to allow it to work with X-ray as an input, but still work the same on that. as it was working before. So what it basically does is it calculates the day number for each day of the year, and then sorts those values. It has a little bit of trickery around February the 29th. So what it does is it increases every year to 366 days, and then interpolates that February the 29th point in there. So it does a lot of creating of arrays. You've got loops that's going to range through the data. You've got detect special cases, and then you've got like a clipping of the algorithm here, and then the threshold is declared as a percentile above the climatology. And then once it has got the climatology, it will then smooth it. Use a boxcar filter, and then go into detect. The detect basically threshold. The detect basically works by using this image, which is basically it's a scikit-learn, not scikit-learn, an imaging thing that says, well, is this pixel connected to this pixel? It's effectively run length encoding, where it says there's got 5 ones followed by 10 zeros followed by 5 ones, and it basically gives you a list of those runs in there. So, and then sets up a dictionary of all the results, goes through, loops across, finds the start and end time of each occurrence of the temperature being above a threshold, counts how many days, and then tries to join them if they're only 2 days apart. It'll join two events together and call them one. And you can see there's a lot of loops in here. And immediately we looked at that and we said, well, can we do something better in X-array, and would it work? Okay. And then it goes through each event and does some statistics on it and passes you back a big dictionary with all the different events in. So what we did, we went over to R, and in R, there's a Heatwave package that's based on this package but runs in R. They've split the climatology part, the detection part, and also what they've done is they return, instead of returning a dictionary, they return it as a pandas frame, and that I was thinking would be really interesting, much easier to work with if this returned a pandas frame with a list of all the occurrences. So I think in the world of Ocean Hack Week, and this was really great, we had 7 contributors to this who all got stuck into different parts. And over the week, this is where we got to. Unfortunately, after that point, it's sort of fallen a bit of a drought. So I'm hoping that this talk might liven up some interest in over here of people who want to just push it that bit further and help it along. All right, so I'll just have a look at the actual code that we came up with, and this is where I really find there's a beauty in X-array, but there's also a sort of a temptation to make one line do everything. And so we set off to look at how we could do this in X-array. And you can make a climatology really easy in X-array. You can do a group by days and a mean and all those kind of things, but it doesn't quite match what Eric did in his original code because of the handling of the February the 29th and things like that. And what we were really keen on is to get something that matched perfectly how this code worked, because this code's been cited and used. So the idea was that it had to match this. So we came up with this package here. Now we followed the calling convention of the R package, which is quite well used. So the R package has 2 functions, TS to climatology, so temperature time series to climatology. and we kept the same calling things. We said, okay, so how are we going to do this in an X-array form? So if we get an X-array object in, the first thing we can do here is say, okay, we get that X-array object. Let's get the day of the year, because basically we're going to work on days of years to get our climatology. And lo and behold, X-array, so easy. ts.time.tt.day of year. Bam, done. So once we've got that, we've got this special case now, and this special case is in leap years, we've got that extra day. So in Eric Oliver's code, what he did is he expanded every year to be a leap year effectively of 366 days. So what that means is we have to add a day to all non-leap years. And this code here, we can do that in X-array using the where clause. So we're saying here, okay, so if the day of the year is greater than 59 and it's not a leap year, we've got these two things. So if that is true, it returns day of the year +1. And if that is not true, false, in other words, it returns the current day. So what that will do is add 1 on to every day that's above February the 29th or 28th, February the 29th, 28th, and then pass you back the new days of the year. So it's made that gap. Then the next object of this object thing was the smoothing. So again, the smoothing, it's quite an interesting, I'm gonna run this, and I'm gonna run this so I can show you the some outputs, because that's kind of handy. Is this okay with everyone? I'm just, it's kind of like an in-depth look at some code, but I think it's got some value from the X-array point of view. So here we go. I'm just going to run this, and so okay, so when we get to this point here, this is kind of really cool actually, because what we had to do was we've got a window, and we want to take the mean over that window, but because we want to stack them up, we want to take this and stack it up so it's years and days this way, and then take the mean across days and years. It proved quite difficult to work out how to do that in X-array. And well, it proved difficult for me, but maybe not for others. Yeah, so I came across this function. Obviously, rolling's the function we want to use. It applies a rolling mean. But then we wanted to construct the mean slightly differently. So if we do rolling, and this window function is just really interesting. So we take the rolling mean, and rather than generating the mean instantly, we say construct window dims. That actually constructs all those box means that it would have done. It constructs them all, and then I can set the index the way I want and unstack that. That's a super, super dense bit of X-array there. It's just like mind-blowing what this is doing. You know, it's a super dense bit of X-rays. And if we run that and see what happens, see what it is, here we go. We run that and have a look in here in the debug console and have a look at what that produced. You can see here, it produced a array of days, but you can see that the window dimension, which is 11, the days of year is 366 and 31 years of data in this. This is a synthetic climatology that I'm using. So if I do T1 dot select year day of year equals 1, that would actually get me information from the first day of the year, and there's 11. That's 11, so that's going plus and minus a few days either side, 11 days either side, and it stacks it up in 31 years. So now when I take when I do a reduce on that, I can reduce it using this next line here and reduce it using nan mean by year window dim, and that will get me the mean of that few days in the year. And the thing is that the mean is actually calculated each year of those 11 days plus or minus every year, and it produces me the result in just a couple of lines of code, which is really dense code, but it's pretty. I mean, I'm always so impressed with Xarray. So I do that, instantly does it. Then I just take out the day, and this is the same as Eric Oliver does, takes out the day because that's got fewer values in it, and then interpolate the missing window, and then go into producing the threshold, again using the reduce command, window, dim, quartile. So that was the other problem. In order to get the percentage quartile, you had to have all those days. And I couldn't find a rolling quartile. So without the window dim, I just couldn't do it. And I was, stumped. Again, it takes that threshold and interpolates out. And then if you've asked to smooth it, it goes to smooth it. One of the things that is really good with climatology, again, I'm a computer scientist, not a climatologist, but it's really bad when you get off December and January the next year don't match. That's a funny artifact of not doing your climatology right. So what I do here is I use the pad command and the wrap mode, and that basically pads the series with us. So when we start and stop, we don't get this funny starting and stopping. And again, for the threshold, once I've done the rolling smoothing on it, then I just drop out those values and take the padding back out again, and off we go. So that's basically it. That'll generate the climatology. And then we want to detect, we've got a threshold, and we want to detect a day that's above the threshold. So the easiest way to do that, again, is get a Boolean. With the slash. Yeah, that is true. I think I've broken the PEP. Is it PEP 5? The Python formatting, but the / transpose. Yeah, that's much more readable. PEP 8. There you go. There's so much to learn, which is why I like Python. So then what we basically, the goal of this is we want to detect how many days it's been over the threshold, so we can say, okay, we're only interested in marine. Our definition of marine heat wave is 5 days over the threshold continuously. So here, this piece of code, I think I forget where this came from, but basically this does run length encoding. And yeah. Yeah. Run length encoding. And run length encoding basically is a standard encoding technique for compression that you look along and say, oh, okay, we've got 5 1s, so I'm going to code that as 1 times 5. And then I got 5 zeros, so it's going to be 0 times 5, and so on and so on. So this code basically does run length encoding, RLE. So my detect, so the detect thing here basically says, okay, how can we do this? So we send in the observation and observations. We send in the threshold, the climatology, and we want to have a look at how this is going to work. So, yeah, the start, we want to find the start points and the end points. Let me just find, okay, so this here is actually processing the event. So if we go down, we're going to say, okay, this is the crux of the matter is just down here. So here, these 2 lines, we're going to take the observations, we're going to group it by day of the year, and we're going to subtract off the threshold. And if it's above the threshold, it'd be greater than 0, which means it's over the threshold, which gives us a true in the Boolean sense. So that'll give us a whole heap of effectively 1s and 0s. If it's 1, it's over the threshold, could be a marine heat wave. And if it's not, it's 0. So then here, this run length encoding, I'm going to take those Boolean values and with a minimum duration that the user has set, and we get a series of runs and so out of there. So then became the issue of we want to join events that are, say, 2 days apart and join them together, and so on and so on. And again, that was another one of these things where you're always thinking to yourself, there must be some way of doing it, using pandas, using something, not just writing a loop and this minus that and joining things together. And so I came up with this solution from reading around the Stack Exchange, but it was quite an interesting solution that I hadn't seen before. So basically what this does, it says, okay, create a data frame from records, the start time, we take the index of all the time values from the Boolean, and we get the end time from the end times. So we're going to create this data frame and create a column start time and end time, and that gets us our pandas frame. And then this is what really sort of I don't know, this is a bit of, I don't know, you could say it's kind of hard to read, but I think it's beautiful pandas here, where you've got a group by and you say, I'm going to group by the start time minus the event time, end time shifted by 1, with if that gap is max gap 1 time delta max gap in so many days, do a cumulative sum and then aggregate start min max to start end time, and then get me that back. And what that does is it basically closes up all the 2-day gaps and things like that for you, and supplies you with a series of joined times without those minimum gaps in there. So that was pretty impressive. Well, it was to me. And yeah, then basically just go through the events, and once you've got the events, I do an apply, and it apply this function, process the event along axis 1, so it's just going to go down, and each time it applies this event, where it's going to say, oh, take the item, it does the observations, gets the start and end times of the observations, crops them out, does gets a marine heat wave. It does the same climatology things that Eric did in his original code, pretty much. But again, using that pandas apply in theory that should parallelize out, and maybe I should be using a Dask data frame there, probably. So then you get a list of possible marine heat wave events. Whew. All right, I'm just going to take a quick breather there and ask if there's any, how are we going? Any sort of questions at all so far?
I haven't seen any pop up in the chat, but maybe people would like to unmute themselves and ask anything that's on their mind.
So this trick with extra day, is that like, so it's really important that you keep this behavior, right, between the new version and the old one?
How should I say this? The goal of the project was to reproduce the original code, right? I'm not a climate scientist. To me, it seems crazy, but you know, that was the goal, to get the same result. If you don't have that extra day in there, the results are just different.
Yeah, and I guess you're not using date axis because there is no 29th.
Yeah, I think it's, and that when you look in the code, in the original code, there's all kinds of, those modelers do all kinds of strange stuff with like 360 day years, 366 day years, 365 day years, you know, whatever
So
makes their model work.
So there is just a day of the year integer axis kind of is a common thing in this domain.
I believe so, yeah. All right, so
thanks. Sorry, Nick. Thanks for going through that. A couple of things. I think we started to discuss this a while back as well. This provenance, or this ability to absolutely duplicate Eric's code, is really important. But I think, as he even said in our quick chats, you know, like, it doesn't mean that has to be the only thing this code does, right? So you could even imagine that, like, for example, it would be maybe great to get a single data set from him that's like the data set we're supposed to compare against and the result. And then you could even have a flag, like, do you want to reproduce the Oliver approach? But then have, if you find you want to do a different approach, that could also be included in the code. I think he was kind of saying that he didn't necessarily want to hold back progress, but at the same time, we want to be able to document, you know, we want to be able to leverage off this published result.
Yeah, I think that's true. And when I looked at our implementation of this code, they've done the same thing, and with the same, handled the days the same way in R. So it was really one of those things where there's, you know, I reckon, yeah, it's good to match. And that was also about keeping the scope of this project down a little bit. There's a lot of people working on marine heat waves, putting a lot of time and effort into various packages. So the scope of this was just sort of narrowed to something achievable, I guess, for Ocean Hack Week.
And that's super valuable, right? And I think you raised the fact that there are a lot of people working on packages, and like even in the past like few weeks, I've discovered that people in Clex already have X-array based marine Heatwave packages, but they're not public yet, but they're currently private. So I guess one of the things we also discussed was, by going through this, you've really developed some expertise and skill in how this thing works. But I think from a community point of view, it'd be great to just have one package that we all kind of, we all kind of rally around. Not saying it's not this one in front of us, but I know that Hillary Scannell in Ryan's office was working on something called OSTrack, but I haven't seen any progress on that. Doesn't mean there's no progress, it's just not on the repo. Anyway, it's just a real, I think what you're doing here is great. And I think you'd agree that at some point we just want to have one package to rule them all, if that makes sense.
For sure, for sure. It wants to be the Marine Heatwave Toolkit or something, because I think that the other thing is that a lot of this work now has gone past the single climatology. You've got model grids, you've got all kinds of stuff. How do you handle the depth integral and all those kind of things is really an active topic. You know, this doesn't have any concept of the thickness of a marine heat wave, right? Yep. And all those kind of things, which are really important things. And, you know, so I think there's a lot of scope to improve things. I'd be really happy, you know, to me, this has been a learning exercise, but I'd be really happy to join in with any group that's making progress.
Yeah, I guess I haven't seen one yet, but maybe this Klex one is mature, but that's through Paula and her team, but I'm going to have a chat with her in a few weeks and see if that's advanced. Anyway, I think this is great, but I am flagging that, like, I haven't sat down to write this code. You have, but I would love to see like a package that probably 10 people have their eyes on to really kind of, have it as mature as possible.
And I actually need that for this IMOS project I'm doing. I need that kind of package, right?
Yeah, I want to chime in quickly. Hillary Scannell is in my research group. And so I mentioned before, I know almost nothing about marine heat waves. I've read like 2 papers that she sent me. But I know she's actively working on OSTrack. I don't know exactly what it does compared to this, but I dropped the GitHub link in the chat. But I know she's, actively working on it. I think she's working on tests at the moment. So it sounds like she's making progress. So I'm sure she'd be happy if you reach out.
Yeah, I
thanks.
think
Thanks. We did reach out. So yeah, I think we did talk to her in February. It's just that things were quite new. But yeah, and now of course Nick is motivating this discussion. So I'm just kind of I've had a quick look at the repo. I just don't, maybe I'm just missing it, but maybe there's some work in a different branch that I'm not seeing.
Yeah, that could be. I've just hear her updates and actually haven't used it myself, so don't have more to say. But yeah, clearly this is a hot topic right now.
Yes, good dad joke there. Marine heat waves, hot topic. Yeah.
Oh yeah, very intentional.
And it's great to it's great to catch up with you, Paige, because it's good that we have somebody in that group in our time zone, which is brilliant.
Yes, glad to be that person. I wish I knew more about each of these things.
All right, so
sorry to interrupt. I was just couldn't click the link from the chat, so I was just searching for it on GitHub, and it does look like there's a development repository as well, and I'm not sure if possibly that's hiding some of the newer work and the newer features you were just talking about. I can put a link to that in the chat too if people would like to have a look at it. I'm not familiar.
Yeah, that'd be great if you don't mind. I'd like to take a look.
That'd be good. All right, so that being said, we have we've done about 40 minutes or so. So I think it'd be kind of nice to sort of switch and just run this code and have a quick look at its output, and then that's probably about as far as we can go right now, unless people want to spend some time you know, writing fancy plotting routines or something like that, or investigating the package. So did everybody manage to get that binder session fired up? It's probably gone to sleep since I've been talking so long. I hope not. Oh, yeah. Yeah, mine's gone to sleep. All right. That's problematic. Okay. Now I have to remember everything I did in order to make that work. Oh dear. All right. Okay, so I'm going to click on the binder and get that up and running. And I suggest we all do the same. So I just clicked on this one here, binder. That should fire me through here.
And we'll also say, Nick, somebody's just asked if there's a link to the tutorial from them making the most of, I guess the question is whether there's a link to the tutorial from what the main page that's on the Dask Summit website. Maybe I can jump and clarify what.
Oh, yeah, I had missed the last tutorial, and I was wondering if there's like
Okay, I will.
That available.
Okay, well, this is actually, I'm actually starting the same, starting the same point as the last tutorial. I was just going to add some stuff to it.
Yeah, to be honest, I think that confused me slightly when I opened the link today. So yesterday with the X-ray tutorial, we opened the same My Binder link and I think started with the X-ray notebook that's at the bottom there, and then maybe moved on to the Dask one.
Yeah, that's right.
Is this the one about the scheduling backends?
Yes, that was the Dask array, but
okay.
What I was having problems getting getting some compute sorted out. So I thought we could just sort of hijack this session and use it for marine heat waves. So the way I was going to do that was just generate a new untitled notebook, and I was going to go and get the Heatwave code, which was I'll post this into.
Could I ask a quick question, Nick?
Yeah.
So is there a reason we're not using the binder links that are in the repo that you have here?
I think that's because they go to the Ocean Hack Week. Well, we could try that. So let me, in this binder here.
Yeah, I think at the if you even go back one, if you just scroll down, there's a button to click Launch Binder in either AWS or Google.
Oh, all right. There we go. I'll give that a try.
Cool. I'll give it a try as well.
Wow. Somebody's done more work. That's the great thing, isn't it? When other people do work, it's great. Let's see if that works. Does everybody follow that? So if do we need to post that into the chat? There we go. The suspense is killing me.
Maybe this is a bad suggestion.
No. It's
We'll find
because
out.
it hasn't built this image, I don't think, before, which is why it's taking a little bit longer.
This is maybe it's worth dropping this separate link in the chat if you think it will take a little while for it to build for everyone.
Yeah, let me just.
Or maybe we'll be lucky enough that it'll build itself and then be a bit faster for everybody else.
So that was I was dropping this link in here, wasn't it? I think I just did it in Pangeo Binder. Where's the chat got to? That is my local copy of it. Dismiss that, dismiss that. Is that going to launch? I think what might be happening is the environment. Yeah, this will be it. I think the Ocean Hack Week environment is probably we look in Binder here. Is it environment.yaml? Yeah, this is what's happening here. This is the full Ocean Hack Week environment with like HoloViews and scikit-learn.
Everything for the whole week, and we're only going to use
yeah.
a bit.
yeah. That's probably why it's grinding a little bit there.
HoloViews is pretty beefy.
Yeah.
We'll get there.
Yeah.
I had a quick question. Just wanted to make sure. So when I was asking about the resources from the last tutorial, I just posted a link to the tutorial that I meant. I just want to make sure that that's the right one.
Okay. So that wasn't a tutorial, that was a talk. Yeah.
Okay.
Yeah, that was just a talk, and the presentation should be video-wise should be available in the next few days.
Yeah, might be longer than that. I'm told that they'll be doing a bit of like light sound editing and adding, title cards before videos. So I'm not sure how long that will take, but definitely have them up as soon as we can.
Okay. Oh, thanks.
Yeah, that is certainly spinning its wheels. So what it might be doing is asking for more resources than they're happy giving us for free.
Nick, I do remember the Ocean Hack Week Slack. I'm talking about shutting down the Binder resources. I could be wrong, but that's my memory. There was a notice about that. So
yeah,
maybe you'll be lucky. It's not because the Binder is grinding, but I do need to go. But thanks. I just wanted to thank you and Genevieve and Paige and others for a good summit, and we'll see you all soon in the rest of the summit.
Yeah, thanks for coming, Thomas. And I think it's been really helpful for our community over here, this sort of get together, and look forward to catching up on Ocean Hack Week.
See you guys soon.
See ya. All right, I'm just going to go back to my original plan. why is this now doing really strange stuff? So originally I tried launching this binder here, which was this one. This one seemed to launch fairly quickly and easily. There we go. So that one launches a lot easier. So if you want to try this one and follow along, feel free. And then I just I'll just make this bigger and I'll paste it in the link. And Ocean Hack Week is here, go here, get the code. And this is what I love about Binder, about this kind of stuff, that there's just so, I stick that in there. I'll just hit go on that. And lo and behold, I'll stick that there. So if you create a new, untitled notebook, and then just type that in, the exclamation mark means it's a shell command, then git clone and Ocean Hack Marine Wave Heatwaves. That will then copy there, and all of a sudden you've got this directory over here with some code in it. But I happen to know that that in this pip upgrade. Here we go. In this particular binder, the version of Xarray doesn't have a function that I use, which is the indexing function. So if you then do that, I'll post that in here. You should actually have a notebook which will work for us. So we've git cloned Ocean Hack Week, and then we have to install the Ocean Heatwaves project, which I believe is /pip install -e and /Ocean Hack Week. There we go. So there, I run that. Oh, beautiful. There we go. And this one here. So those three things. And an interesting thing about this, when I do the pip install -e, and that puts it into your local environment, which is really cool for when you're doing, when you're developing code. It means that you can set breakpoints because the file is not moved out your GitHub. If you've got a repository with the file you're working on, normally when you installed it, it would then put that in some system file over here. But if you do the -e, it just keeps it where it is in place, and you can set your breakpoints and everything's a lot happier. All right, so a quick sort of show of hands or cough, or is everybody anywhere near that point, or have I lost everyone?
Just for me personally, I've opened the My Binder link and opened a new Python 3 notebook in it and run that git clone command in a cell. And then I was doing a lot of typing so that I could copy these instructions over to Slack later. So I've just pip installed the newest version of Xarray. Other people may or may not be a little bit further ahead.
Okay, so worked well for me. Great. Okay, so now, I mean, there's not actually a lot to see here, but I'll just show you a quick run of the code. So if we go to Ocean Hack Week here, and notebooks, it's a little bit messy, all this stuff here, notebooks there, and then there's a marine heatwave test notebook. So if I open that up, this line at the beginning, this is a note for developers as well. This is really cool. So often what I do is I run this notebook, and but I'm also got my development environment editing the same package at the same time. So the first cell lines here, what that does, this auto reload here, it puts a watch on my library, my Heatwave library, or all the libraries that I import. And if those change, it automatically reloads them, so you don't have to restart your kernel and all those kind of things. It will just watch what happens. And so if I have a problem, I can go to that, edit it, run my test code inside as go, okay, that's fine now, and automatically reload it into my notebook environment here. Having said that, I don't think it will work on a Pangeo instance that's way, way away. So, okay, that should, that I don't think we need that line. So we import, that was importing the original Heatwave, which we're not going to be using. That should import. There we go, and then run the NumPy. And now we've got this this thing. We're going to use a synthetic climatology with some noise added to it. Eric had this synthetic climatology function built into his Heatwave package. So I just copied that and made it return an Xarray object so that we could plot stuff. Here we go. So if I plot this, it should produce this plot, and you can see there's seasonality there, and there's a bit of a quite jiggered. So if we, you know, we can zoom in on bits, and then what we had here was the I've included in this toolbox the original lightly edited, full of loops marine heatwave detection code. And initially I ran it with no smoothing on, because then it's a lot easier to see what's happening. So if I run that now, that should run and detect the thing. So that's basically saying all time 10 seconds. Now we run the equivalent climatology routine here. We're on, this is an Xarray, we're on 498 milliseconds. So instantly, I think that's quite a nice speed up. I think in the background, Xarray by default is using a local cluster. I'm not sure, but in this thing, our local cluster is like one CPU with one thread. So there's no real parallelism in it. So the original client, and this is produced climatology. This is from our Xarray climatology, and this is the original Python climatology. We've got smooth percentile and false on both. We just have a look at what it's produced. It's produced a climatology with days between 1 and 366 and some Z's here. So I just did these plots just to convince myself. That's the climatology there. One plotted on top of the other, and you look at it. It's the southern hemisphere, of course, because it's hottest at Christmas, and winter it's coolest. So that's kind of nice. And you can see here we've got everything is looking really good. And then just to prove it to myself, I did the climatology, seasonal climatology minus the original climatology, plot that, and we're getting these figures. That's E times, e to the minus 15. So there is some difference, but it's absolutely nothing. So if we wanted to detect the heat waves, what will we do next? Have a look at, that's the old detection system. And if we want to do the new detection system, we go detect. Here we go. And that should detect event. I'm hopeless without type ahead. There we go. So that detect event. Smooth percentile's already been done. Hey. Oh. So let's just have a look at that. Detect event here would be here. We're taking the observations, the climatology, observations, the threshold climatology, and the duration. So look at that. Observations is our original climatology here. Then the next thing would be, next thing in line here is the threshold climate observations, the threshold climatology, which is here, which is what's it? Where has this got to? Detect event. Detect event. All right, so that should have in here, climatology should have that, which is the seasonal, and then it should have the threshold in here. And that, okay, threshold climatology, minimum duration. So threshold climatology, minimum duration. And this is returning so long as it's a touch code event. So it's only returning one in this instance. New events, there we go. Okay, so that's all time of 2 seconds. There we go. So after it's done everything the other one done, it's still four times quicker. And these new events now, that should be a pandas data frame with a start index, peak time, and so on. Those are the detected detected heat waves from the synthetic climatology. All right, so we should have two things that are roughly the same, well, almost identically the same, and the same output. So now it would basically be up to the person who wants to use this package to go and find a time series of climatology, daily readings from somewhere, and run it through the package. I think that's about where we get to. Yeah, we got any questions at all there? We all managed to follow along to that point. So now, I mean, is that helpful? Is that useful to anyone, or is that just more tutorial baggage? But I think there's some useful insights there. Where I go from next is you need to find a time series that would be at least sort of 10 years or more, that allows you to get that SST. So what we've been working on now is, in the presentation, is to how to do pixel drills from IMOS SST data, because there's the best part of 30 years of SST data, and use those to create a climatology and then put it through this heat wave processing would be the next step. All right. Any questions or any comments that people want to share? Okay. All right. I think that's just about it then. I'd just like to thank everybody for coming along, and if you've got any comments about the package or how it could be useful to you, or you want to work further with it, just hit me up on GitHub or Slack, and see where we go from there.
Yeah, and thank you very much, Nick, for giving this tutorial. I think it was really very helpful to see some of the changes and things that you need to do to get something like this working. So thanks again, Nick. And yeah, I think I'll stop the recording here.